Students, this question was asked in IIT exam in the year 1986. Dimensions of one or more pairs are same. Identify the pairs. Torque and work, angular momentum and work, energy and Young's modulus, light year and wavelength. Okay, student, let us do this problem. What is the formula for torque, student? Tau is equal to F cross R. This is a vector we know, and this is a cross product of force and distance. So the magnitude of tau is Fr sin theta, and this R sin theta is the perpendicular distance. So this is force into the perpendicular distance, students. So the dimensions of tau will be equal to dimensions of force into dimensions of perpendicular distance, that is FLT minus 2 into L is equal to ML2T minus 2. Okay, student, what is the formula for work? If a force F is acting on a body and displaces it through a distance S, then a work is said to be done, and that is given by work is a scalar quantity, and that is the dot product of force and displacement, or this is Fs cos theta, or we may simply say F into L. Okay, student, so what will be the dimension of W? That is dimension of F and dimension of L are MLT minus 2 into L, that is same as ML2T minus 2. So we observe the dimensions of torque is same as the dimensional formula of work, students. Let us see what is the dimensional formula of angular momentum. It is denoted by L, student, and the formula is given by mvr, when m is the mass of the body, v is its velocity, and r is the radius of the circle in which it is executing circular motion. Okay, student, then what will be the dimensions of angular momentum L? That will be the dimensions of mass into dimensions of velocity into dimensions of the radius, or that will be m. What is the dimension of velocity, student? We know Lt minus 1, dimensions of radius is length, so this becomes mL2T minus 1. We know, student, this is the dimensional formula of angular momentum, which is same as that of the Planck's constant we have studied, but this is different from work because dimensions of work is mL2T minus 2, which is same as that of the torque. And let us see what is the dimension of energy, student. Every energy has one dimensional formula. Okay, student, for example, let us take the kinetic energy. Kinetic energy is equal to T, it is denoted by T. T is equal to half mv square. So the dimensions of T will be dimensions of V into dimension of m into dimension of v square, student. Dimension of small m, that is mass, is capital M in square bracket, and the dimensions of velocity is Lt minus 1 square. Then this becomes m L2T minus 2. Okay, students, let us write here. This is the dimensional formula of energy. We can observe this is same as that of the torque and that of the work, students. And what is the formula for Young's modulus? We know Young's modulus, student, that is stress upon strain. The formula is stress upon strain. And what is stress? That is force by area, and strain is the change in length by original length. So, student, or change in the area by original area, or change in volume by original volume. So, student, this is a change in dimension by original dimension. And what is the dimension of force? That is mLT minus 2, and that of area, that is L2. And what is the dimension of strain, student? That is L upon L. The dimension of delta L is also L. This is a length, this is a length. So both will cancel each other, and this will become m L minus 1 T minus 2. Okay, student? And energy has dimension mL2 T minus 2. So these two are not same. Angular momentum and work are also not same, but torque and work are same. Let us see what is the dimensional formula of light year. What is light year, students? Light year is the distance traversed by light in 1 year. So this is a distance, so it will have dimensions of that of distance. And what is distance, student? That is a length. So this will have dimensions 11. And what is it wavelength, student? That is the distance between two adjacent crates or crops of a wave. Okay, students? Then this is also a distance. The distance between two crests and two crops, adjacent crest and adjacent crop. So the dimensions of wavelength is also the dimension of distance, that is L. So the dimensions for light year and wavelength are same, that is L. Okay, students. So A and D are correct. Torque and work have same dimensions, light year and wavelength have same dimensions.